Everybody, it's Miss A, and I'm here with a request video by one of my former students. She wanted to see a video on fractions that we are adding and subtracting that have unlike denominators. Subtraction with unlike denominators. All right, so the first thing that I want to talk about is adding and subtracting, obviously, with like denominators, and then we'll move on. So if I have 5, 6 plus 3, 6, my denominator stays the same, 6, and then I just add my numerators, 5 plus 3, which is 8. The same applies for subtraction. Denominators don't change. Now, the reason why is because you can't take or add pieces that are different sizes. So you have to make them the same sizes in order to add or subtract them. And that's why the denominator stays the same, because the size of the piece for all of them are a sixth. And this would be 2/6. Or its equivalent, which is 1/3. This one, if I were to put this in simplest form, that would be 4/3. All right, so now that's a little quick reminder of how we add and subtract fractions. And I'm sure she's asking me for the next grade level, but I want to go over what we do in 4th grade. So let's say we have 10 hundredths plus 9 tenths. All right, 10 hundredths plus 9 tenths. These pieces are not the same. This one is 110 of those. This is 10 and 9 of those. So for example, if this was 100, 8, 9, 10. This would be one row. This is 9 tenths. And that's 9 of these. So you see how they look different. We can't add and subtract unless our pieces are the same size. So here with this particular problem, we could leave 10 100ths, and we could turn this into a hundredth by taking 9 tenths times 10 over 10, which equals 90 100ths. This is the same thing as saying 9 tenths and adding a 0 to the top and the bottom. If I do it to the top and the bottom, it's still equivalent. And so now I have 10 100ths plus 90 100ths, which equals 100 100ths. Now I also could take this same exact problem, 10 100ths plus 9 tenths, and I could turn this into a tenth so that the denominators match, because that's when we talk about the pieces being the same, the denominators have to match. I could do the same thing by saying 10 100ths divided by 10 tenths, which is the same thing as saying take away a 0, take away a 0. If there's one on the top that you can take away and one on the bottom, you can do this. If I were to have 11 100ths, I couldn't do that because there's not a 0 to take away. So if I were to do that, that would be 1/10 plus 9 tenths, which is equal to 10 tenths, which is still a whole, just like this is a whole. Now let's talk about fractions that have different types of denominators other than 10 and 100, because that's pretty simple concept. We either add a 0 to the top and bottom or take a 0 away from the top and bottom. So let's talk about adding and subtracting fractions that have different types of denominators. So let's say we have 1/3 plus 2/6. What we have to do is we have to turn one of these fractions, or possibly both of the fractions, we have to change it so that the denominators match. That's the only way we can add or subtract them. So when I'm looking at this particular problem, it's easy enough for me. There's a couple of strategies to do. The first strategy is to find out what times 3 equals 6. So looking at your higher numbered, your higher absolute value, which would be the absolute value of this number, is and you multiply it times this. So 1/3 times 2 over 2, because 3 times 2 is 6. That creates my common denominator, which is what you need in order to add or subtract fractions. 1 times 2 is 2. So now I have a new fraction set to add. I have 2/6, which is still equivalent to 1/3, plus 2/6 which is equal to 4/6. And then putting this in simplest form would say I would divide by 2/2, which equals 2/3. So 4/6 and 2/3 are equal. They're equivalent. And 2/6 and 1/3 are equal. They are equivalent. All right. Now there's another strategy to solve this exact same problem. If you can't think, hey, what do I multiply times this to make this? I could cross multiply by each other's denominators. For example, 1/3 plus 2/6. I could take 1/3 and multiply that by the opposite denominator. So times 6/6, that gives me a new fraction of 6/18. And I could take 2/6 times 3/3, and that gives me 6/18. You see how my denominators are the same. And then I have 6/18 plus 6/18, which equals 12/18. And if I were to reduce that by, let's start with 4. Nope, can't do 4 because 4 doesn't go into 16. So let's do 3/3. That would be 4/6. And then I can reduce that by 2/2, which is equal to 2/3. All right. So there are two strategies in order to solve this. I can either look at my smallest denominator and say, what do I multiply times that to equal that number? Or I can cross multiply. If you're good with your multiplication facts, either one would be possible for you. This one doesn't require as much thinking though, because you're just basically cross multiplying. So let me give you another example. Let's do 5/7 minus 3/5. 5/7 minus 3/5. So when I'm looking at these particular numbers, I'm looking for a common multiple among 5s and 7s. So 7 times 1 is 7. 7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28. 7 times 5 is 35. Multiplying against each other is the first common multiple that 5 and 7 have. I did my 7s because I know any multiple of 5 has to end in 5 or 0. So I was looking for that 5 or 0 that would occur within my multiples of 7. So what that tells me is that I have to take 5/7 times 5/5, which equals 25/35, and then 3/5 times 7/7, which equals 21/35. And now I have two fractions that I can subtract because the pieces match. The denominators have to match in order to do that. So 25/35 minus 21/35 equals 4/35. And that is in the simplest form because 4, the only the only factors of 4 are 1 and 4 and 2 and 2, and neither one of those are none of those are factors of 35. So another example here. Let's do 3/9 minus 2. Let's do 2/3. No. Let's do. That's not a good example with minus. We can change it to plus though. 3/9 plus 2. Let's do 2. Yeah, we could do 2/3. Okay. So here's the example. Remember, our denominators have to match, and right now they don't. Two strategies. I can look for a common multiple. So I'm going to go here to my 3. 3 times 1 is 3, so nothing times 9 equals 3. 3 times 2 equals 6, nothing times 9 equals 6. 3 times 3 equals 9. Well, 9 equals 9. So I know that this one's already 9, so I don't have to touch it. This one tells me I have to multiply this times 3. So 3/9 plus, and let me put 2/3 times 3/3, which equals 2. 2 times 3 is 6. 3 times 3 is 9. That's 6/9. 3 ninths plus 6 ninths. Remember, denominators stay the same. 3 plus 6 is 9. It's 9 ninths. 12 24ths minus 3 eighths. 12 24ths and 3 eighths. Now those numbers are really far apart, but I'm going to look for my common multiple with my lowest denominator and see if there's anything times 8 that equals 24. So 8 times 1 is 8. 8 times 2, 16. 8 times 3 is 24. So since my multiple is 24, and I don't have to look for another multiple, I don't have to look for a multiple of that is higher in 24s, I can leave this one alone. So let me go to this. This tells me that I'm multiplying that fraction times 3. So 12 24ths minus, now let me do the math here to make a common denominator with my second fraction, times 3 over 3. 3 times 3 is 9. 8 times 4 is 24. So 9 24ths. 24 over 24 is my denominator. 12 minus 9 is 3. And I know that 8 times 3 is 24, so I can divide both the top and bottom by 3 to simplify my fraction, and that's 1/8. All right, I'm gonna write a couple of practice problems, and I hope this video helps. I am going to do, let me turn it over here. So we'll do 4 practice problems. First one will be super simple. 7 ninths plus 2 ninths. 5 100ths plus 6 tenths. 7 thirds minus 10 24ths. 5 eighths plus 9 fifths. All right, so this one is just simply adding my numerators. Denominator stays the same. This one is adding a 0 or taking away a 0 to one of my numbers and then adding or subtracting. This one is finding a common multiple of my smaller denominator, and this one is finding a common multiple amongst both numbers. I hope this video helps. Thanks for asking, Veronica.